Okay, moving on to the atom. Apparently we have a lot of videos for this one because see, I have my whole list of how I'm going to upload them. So this is video 9. Okay, so the atom is the smallest particle of an element that retains the characteristics of that element. So our learning goal for this is to describe the electrical charge and location in an atom for a proton, neutron, and electron. Okay. Dalton's atomic theory states that atoms are tiny particles of tiny particles of matter of an element that are similar to each other and different from those of other elements. There are 2 or more different elements that combine to form compounds, like we talked about earlier in this unit or module. And they can be rearranged to form new combinations in chemical reactions. And the atoms are never created or destroyed during a reaction. Okay, so that's one of Newton's laws of thermodynamics, that atoms can neither be created nor destroyed, right? So they can just be shifted, but they cannot be created or destroyed. So looking at the electrical charges of an atom, we have protons, and these have a positive charge. Electrons that have a negative charge, and neutrons that are neutral. And so I think of protons as positive, right? Pro positive is usually like pro football is positive. Well, that doesn't make sense, but pro whatever is going to be positive. So that's how you can remember that our positive charges are going to be our protons. Electrons, I think of electronegativity, so negative, right? And then neutrons kind of sounds like neutral. So neutrons have a neutral charge, so neither positive nor negative. And like charges repel and unlike charges attract. What that means is, you guys have played with magnets before, right? If you put 2 positives together, they're going to fight with each other and repel. Well, if you have opposites, attract. So a positive and a negative will interact together, where 2 likes are going to repel. All right. I had to move for a second. All right, so J.J. Thomson is a great scientist, and he had an experiment. It's called the cathode ray experiment. And when he was doing it, he realized that the cathode rays contain negatively charged particles. And these particles, which we now have figured out and can call them electrons, they had a much smaller mass than the atom. And so Thomson proposed a plum pudding model of the atom, in which the protons and electrons were randomly distributed in a positively charged cloud, like plums in a pudding. So everything's food related. Have you not figured this out yet? So here you can see his kind of experimental draw, where the negative electrons were plums, where the positive would be the pudding. Well, then Rutherford came along, and he did a gold foil experiment. And in Rutherford's gold foil experiment, the positively charged particles were aimed at atoms of gold, and most went straight through the atoms, and they were only deflected occasionally. And so the conclusion that Rutherford made was that there must be a small, dense, positively charged nucleus in the atom that would deflect the positive particles that came close. So this was a draw-up of his example, where there's a source of the particles, where the lead container, they had the beam of particles, thin gold foil, and then you can see that some of them were deflected and bounced off, and some went right through. So through some of these experiments, we were able to determine the structure of an atom. And so the atom consists of a nucleus that contains the protons and neutrons, and then the electrons are going to be in a large empty space that's surrounding or around the nucleus. So it's kind of an orbital, so they buzz around there. So just remember that our protons and neutrons are going to be in the center, and the electrons are going to buzz around on the outside. So using this, we were able to determine how to figure out the mass of an atom. And so this is another great flashcard thing, where the atomic mass unit, or 1 AMU, it has the mass that's equal to 1/12 of the mass of a carbon-12 atom. So a proton has the mass of about 1 AMU. A neutron has the mass of about 1 AMU, where the electrons are almost kind of weightless. Okay, they have a very small mass of 0.000549 AMUs. Okay, so we can use these to calculate the different masses of different atoms. And so here's a fun table of subatomic particles in the atom. The proton, which can be either written as a P or a P+, has a positive 1 charge and a mass of 1, and its location is in the nucleus. The neutron is neutral charge, remember, and that also has an atomic mass of 1. And again, location is going to be in the nucleus. Where the electrons are little buzzy guys, they have a negative 1 charge and are almost weightless, but they do have a very small charge, and those are found orbiting around or outside the nucleus. So here is a fun study check for us. Which of the following subatomic particles fits each of the descriptions below? Proton, neutron, electron. So pause for a second. Okay, the electron is going to be found outside the nucleus. The proton has that positive or pro-charged, where the neutron has has mass but no charge. So I hope that this was fun.